Okay, so let's have a look at 7b. And so if you've got your notes book there, you might look at that and go, gee, that looks pretty overwhelming, all of that text and so forth. But I think what we'll do is we'll start with the example and then we'll reflect back on each of the notes here and how that they pop up. So we have what's called a probability distribution. And basically, maybe we'll jump about halfway down where we have a fair coin is flipped twice. Okay, so we have a coin and we're flipping it twice, and we're going to say the random variable x is the number of heads we get. So if we're flipping a coin twice, we could get 0 heads, 1 head, or 2 heads. All right, and so I've listed the sample space in brackets and the corresponding probabilities. Okay, it's more probable that you'll get a head and the tails than 2 heads or 2 tails. Okay, so we can display this in a table. Now this is what a probability distribution is, okay? It's a table where we have x, lowercase x describes the possible events. So we can have 0 heads, 1 heads, or 2 heads. And then what we have is we have the probability that our random variable takes on the event x. Okay, so the events are 0 heads, 1 head, or 2 heads. Our random variable is the number of heads. So the probability of the number of heads being 0 is a quarter, a half, and a quarter. All right, so that's what a probability distribution is. We can display it as a table or a graph, listed both there. Then we have, just keep reading down, we have a uniform discrete variable as a special case where every event has the same probability. Okay, so for example, rolling a dice. So we would have the events are 1, 2, 3, 4, 5, 6, and the probability 1 on 6, 1 on 6, 1 on 6. That's uniform because each probability is the same. So keep going down, we have the mode. The mode is the event with the highest probability of occurring, and the median is the event that corresponds to the cumulative sum of probability reaching 0.5. So we'll explain that right now. Okay, part 1. Consider the probability function, probability density function distribution below. Okay, so we have the events 1, 2, 3, and 4. And the probability is 0.2. We have here k, we have 0.24, and we have 0.22. All right, part A says, find the value of k. Well, what I want to point out is a probability distribution has 3 properties, and those are listed in the dot points at the top of the page. The first is that every probability must lie between 0 and 1. So you can have a probability of 0, that means it definitely won't happen. Probability of 1 means it will certainly happen, and most events will occur between 0 and 1. So all probabilities must lie between 0 and 1. The second dot point says the sum of all probabilities has to add up to 1. Okay? All probable events add to 1. And then we've got the third property, just describes the probability distribution. Okay, so what we're going to say is that all of these probabilities have to add up to 1. They all have to be positive as well, by the way. You can't have a negative probability. So if all of these add up to 1, we can make a statement like this: 0.2 plus k plus 0.24 plus 0.22 equals 1. And we can solve through for k. What have we got there? 0.44, 0.66. So we'll get k is 0.34. Okay. Part B. Is this a uniform distribution? The answer is no. A uniform distribution is a special distribution where each probability is the same. Here we have different probabilities for each event. No, we can just say probabilities differ, or probabilities not uniform. C. Find the probability of the random variable being larger than or equal to 2. So what this means is event 2 plus event 3 plus event 4. Now notice how all of the events add up to 1. Okay, so we can just go 1 take away 0.2 is going to leave us with that sum there, or you can add it up. Okay, find the mode of the distribution. So the mode is the event with the highest probability. So we saw before the value of k was 0.34, so the highest probability is 0.34, which means the mode is the event is 2. So the mode is 2. And the median is the event where the cumulative probability, so what we're going to do is we're going to add the probabilities up, so we're going to go 0.2 plus 0.34 until it reaches or exceeds 0.5. So at 0.2 here, we haven't got to 0.5 yet, okay? When we move to here, we go 0.2 plus 0.34, that gives us 0.54, which means we have reached and exceeded 0.5, so this is the median event. So that's for part E, the median is also 2. So we'll have a number of examples that display that median a little bit more. Okay, so that's a probability distribution. Just note that all probabilities need to lie between 0 and 1, and that, that's how we calculate the median and the mode. So we do have probability distribution functions. I think we'll just go through that now, because then we can sort of set it for homework. So we'll clear some space here. Any questions about the distribution table? Okay, so we have a probability distribution function. So sometimes it'll be a table, sometimes it'll be a function. Kx on top of 4, and we're told it's valid for x is 1, 2, and 3. Okay, find the value of k. Now, because it's valid, it means all of the probabilities add up to 1. So that means when we put in x is 1, we have p of 1, plus p of 2, plus p of 3. That's going to add up to 1. That each probability will add together, will add up to 1. So we'll put those numbers in here. We would have k on 4, plus 2k on 4, plus 3k on 4, equals 1. And we're just solving through for k. So what's that? K, 3k, 6k on 4. Times by 4 and divide by 6. Okay, so we've started with the function, and now it wants us to draw this distribution. Okay, so what we have is we have x, and then we have, so the events. The events are x is either 1, 2, or 3. They're the possible events that can occur. And then we have the probability that the random variable takes on that event. Now, if k is 2/3, what we're going to do is just put k into each of these in order to determine the probability of each event, right? So if k is 2/3, if we put 2/3 in here, 2/3 divided by 4, that'll be 2 on 12. In here we would have 4/3 divided by 4, it'd be 4 divided by 12. And in here it'd be 6 divided by 12. Okay, so I'm putting that k value in here. So what you're technically doing, I mean, you can use your calculator if you want to, but we have 2 times 2/3. I'll put it into this one. 2 times 2/3 divided by 4. So that's 4 on 3, on 4 on 1, AD on BC gives you 4 on 12. So that's how I've evaluated those. Okay, find the median and the mode. Okay, so the mode is the event with the highest probability, which is 3, and the median is the event such that the probability exceeds 0.5, right? So when we try and, now there's a couple of ways of describing the median. When we add these up, we'll have 2 on 12 plus 4 on 12. That takes us to 6 on 12, which is 0.5, right? So what it means for this distribution, how can I sketch it? Basically, we have events 1 and 2 have a probability of 0.5. So that's events 1 and 2. And then we have event 3 has a probability of 0.5 as well. So when you think of the median is the point that lies exactly halfway through the data set, right? So the median has to lie in the middle of those. So what's in between 2 and 3? 2.5, yeah. Okay. So we'll accept 2.5. Some people say that there's, some people would list 2 and 3, that the median lies in between there, but 2.5 I think is a good way to answer it. Okay, why is that? Because half of the probability occurs here, and the other half occurs here, which means the median is halfway between. Okay, so what we did there, we moved from a function to a table. So in 7b, they'll start off by asking you about some tables, and they'll say check if they're valid. So what are the valid properties? All probabilities add to 1, and all probabilities lie between 0 and 1. That means you can't have negative probabilities, and you can't have probabilities above 1. But that'll be a good exercise to crack through, and that'll be where we stop. So yeah, see how you go with that one.